Ever wonder how a prosthetic hand could really feel like a natural extension of your body? Today, we're diving into a breakthrough that's making that vision a reality. Let's break down how researchers taught a prosthetic hand to grasp, lift, and release objects with near-human precision, without needing complex sensors or endless training. So the big challenge here is this. Traditional prosthetics often rely on muscle signals or pre-programmed movements, which can be slow, error-prone, or require users to learn complicated control schemes. But what if the hand could learn by watching? That's exactly what this study did. Here's how it works. Instead of relying on electrical signals from muscles, the team used a wrist-mounted camera to capture visual cues. The prosthetic hand then uses AI to mimic human-like grasping. But here's the kicker, they didn't just teach it for one person. They tested it across 9 participants, averaging results to see if the model could generalize. And the numbers? Let's talk about them. For objects people had seen before, like a banana or a Coke bottle, the system nailed it. On average, it succeeded in 98% of reaching and grasping attempts, and 99% for releasing and retrieving. But the real test? Unseen objects, like a multimeter or a Gatorade bottle. Even there, it managed 97% success on average. That's huge. It means the model isn't just memorizing specific items, it's learning patterns that apply to new objects. Now, let's unpack why some tasks were trickier. The lifting, holding, lowering phase had a slightly lower success rate, about 95%. Why? Well, lifting requires balancing grip force and stability, especially with small or slippery objects like a ping-pong ball or barbecue sauce. The models got to feel when to tighten or loosen, and that's harder to perfect. But here's what's even cooler. The system worked across all 9 participants without retraining. That means it's not just good for one person, it's adaptable. Imagine a prosthetic that learns from your unique movements, not some generic template. It's like having a teammate that gets better the more you use it. So why does this matter? Think about the everyday struggles people with limb loss face, reaching for a cup, opening a jar, or even typing on a keyboard. This tech could make those tasks smoother, less mentally taxing, and more intuitive. It's not just about functionality, it's about reclaiming a sense of normalcy. But here's where the science gets clever. The team trained their system using teleoperation, a process where a human demonstrator physically controls the prosthetic hand while the system learns from their movements. It's like teaching a kid to ride a bike by holding the seat. However, even this method isn't perfect. If the hand touches the table instead of the object, the grasp fails. Yet the researchers discovered a key insight. By analyzing how humans adjust their grip in real time, the AI could infer optimal force and positioning. This approach addresses 2 major hurdles: user errors and algorithm flaws. Think of it like learning to drive a car. If you hit the gas too hard, you might skid. That's a user error. But if the car's sensors misread the road, that's a system flaw. For prosthetics, if a user moves their hand too fast or positions it awkwardly, the device can't keep up. But the real challenge was algorithm problems, like a hand that closes too quickly, missing the object entirely, or gripping too softly and letting it slip. These aren't just bugs, they're clues about how to make the tech better. This research is a stepping stone toward prosthetics that don't just follow commands, but anticipate needs, adapt to environments, and feel like a natural part of your body. While there's still work to do, the path forward is clearer than ever. For the first time, we're seeing a prosthetic that learns like a human, adapts like a teammate, and bridges the gap between technology and intuition. Ever wonder why a prosthetic hand might drop a mug or struggle to pick up a feather? It's not just about the technology, it's about solving a puzzle that's as complex as human movement itself. Let's break down the science behind making these devices smarter, smoother, and more reliable. Researchers diving into this challenge found that the biggest obstacles weren't just hardware limitations, they were systemic. The AI models often overestimated grip strength or misjudged object shapes, leading to failures. But by combining visual data with real-time feedback from human demonstrations, the team created a system that's both robust and adaptive. Imagine a world where your prosthetic doesn't just react to your commands, but understands them. Where it learns from your unique way of moving, rather than forcing you to conform to its rigid programming. That's the future this research is building. And it's closer than you think. So next time you pick up a cup or type on a keyboard, remember, the science behind prosthetics is evolving faster than ever. And with breakthroughs like this, the line between human and machine is getting blurrier, better, more intuitive, and more human than ever before.